Hello and assalamu alaikum everyone. We are back with episode 16. In fact, this is episode after 17. This was the episode that got missing for some home emergencies, and we could not uh, go online with this episode, so it was remaining. We have Sir Nouman Shamim once again with us, and he would definitely be helping us today with binary trees ADT. Sir Nouman.
Okay, we'll start with the binary tree topics. We'll start with this. Uh, Binary tree, as we are like those who have already done the linked list, is the type of ADT abstract data type. The basic difference between a binary tree and a linked list. In linked list, you will see a pointer, a node is actually pointing to the next node, while in binary tree, a node is pointing towards two nodes. It could be a leaf, like it could be a right node or a left node. So if you look at here, uh, binary tree is the tree which each node contains two child nodes. You can see there are three figures. Figure 1 is not a binary tree. Why it is not a binary tree? You can see there is this node, it's actually pointing three nodes. In binary tree, a node can be pointing at 0, 1 or 2 node at max, not more than 2. When you see is figure 2, it's example of binary tree, but it's not a complete binary tree because this one, like this node doesn't pointing on this thing. And then this one here, it's called a complete binary tree where each node is pointing two nodes except for the last node that is called the leaf node. The top node is always called the root node from where we start, and then the bottom, these are the child node, and then each child node has another two child node. The last nodes are called the leaf node. We call them the leaf node because they are not pointing on anything. That's why we call them the leaf. There are two types of binary tree. In order binary tree, the left child node will always be less. Like you can see here, the 6, when like the first root node has the value of 6, because the 3 is lesser than 6, so its pointing is on the left hand side of the 6, while 9 is greater than 6, so it's pointing on the right hand. Similar case follow here. You can see it's 3, 1 is less than 3, so it's pointing on the left side of the 3, while the 5 is pointing on the this side of 3. Is it clear? There are different operations that can be performed in binary tree. They're like traversing, insertion, deletion, and uh, searching. We are going to look at the traversing, insertion things also. Deletions will okay. What are the like? These are the basically different types of operation that can be done in a binary tree. The things applications, if you look at the binary application, there's an expression evaluation, like you see the mathematical expression evaluates the tree structure. Similarly in data searching and also in the data sorting, these are important points that can has to be noted. Okay, a binary tree can be represented by using an array. We'll basically definitely, this is our main topic where we're going to look at is a binary tree will be representation with the array. You can see here the nodes, and the key concept is that if a parent stored in a location k, then is the left and right child are located in 2k and 2k plus 1. You can see these are the location of array, the element, like you can imagine that array is of 7 elements. The first location is the root location, obviously 6. Now you can see the location that are moving through. The next value, that is a left pointer, that is always on the left pointer because 3 is lesser than 6. It's on the 2. And then the right pointer is 9. You can say 2 plus 1 is always be the next. You can just have to plus the value and you will find out these things there. Now there are different type of traversing that can be done. In pre-order, we will definitely look at the code of these things, insertions and pre-order traversing also. Pre-ordering process the root node. You will have to start with the root node, then you have to go to the left subtree, and then we will go to the right subtree. Similarly, in order process perform in order traverse of left subtree process the root node perform in order traverse of the right node. We start with the leaf node, left subtree, then the root node. We look at all these things. And the post order traverse, will you perform post order traverse of the left subtree, perform post order traverse of right subtree and project. That means you're starting with the leaf node and then you're going through the order. Pre-order and post-order as appear in the list. In pre-order, you start with the process with the root node and then go for the left and right. While in post-order, you will start with the leaf. Let me you start with the leaf subtree, also leaf nodes from the leaf subtree and then the right subtree and then go to the root node. This is how this can be done. You can see the pre-order traversal. What we have done here in the pre-order traversal, we start with the root node, that is 6. Then we will move to 3, that is obviously the left side, and then 1 and 5. Then we go to the right, and then we go for the. You can see the in order travel. What we say in order, we start with the left leaf T node, that is 1. Then we go to the root node 3, and then we go to the. And then the last one, that is called post order traversal. You can see what we have done. We will start with the left tree, then the right tree, and then we go to the root node. Similarly, we then have left tree, right tree, leaf node, and then we go to the main tree. This is how these things are. Now, how to declare a root node? You need to remember, you need to define a class called structure tree. I'm just using the Visual Basic pseudocode here. You can also see okay, this will be much better. So we look at this code here. Okay, now if you look at the code here, what we have done, we have made a record data type of structure tree where we have two things. Data will be obviously the pointer, and left pointer and right pointer, and we call this, give this name a tree. We are basically now doing how to insert data in the tree structure. So you can see the different variable is there. I have used different variable. The important thing is here, that is called dim binary tree as tree. B tree as tree. That is basically what I have done. I have declared a array of 5 elements. 0 to 4 is 5 elements, and that array contains 3 things. What are the 3 things it contains? You can see here. It has left pointer, data, and right pointer, and you can see these values, right? Initially, when we have declared this, you can call this thing like you can call this 3 things. We can call them what? These things are actually a tree data type जो कि हमने अभी create की है. It contain a left pointer, data, and right pointer, and automatically the positions of these things are being done. So this is 0, 1. These are array element 3 and 4. You can now have this pointer here. How to initialize this code will actually going to initialize the null pointer. What is a null pointer? A very important concept. Null pointer, like instance, a pointer that is normally assigned to a leaf pointer, which is not pointing to anything. Not only leaf pointer, there are some also nodes which are not pointing. We will see in the code, or will always. Any node that is not pointing, whether it's on the right or left, will be known as a null pointer. Remember, if you are writing in any programming language, you'll always have null pointer -1, while in pseudocode you can have it as 0. Then pre-pointer as 0, we have already, obviously that means pre-pointer, the first line list that is pointing is 0. Now what we have done here, we have said for count is equal to 0 to 3. What we have done, B-tree, remember, we have declared the array with the name of B-tree. B-tree count dot left pointer is equal to count plus 1. We all know when the first time the loop will run, the count value will be 0. B-tree count dot left pointer. That means B-tree ka 0 ka left pointer. If you look at here, we are actually talking about this. This is binary tree. The left pointer of 0, this is the value. It's basically the value is equals to what? It equals to count plus 1. 0 plus 1, the value will become 1. So what I am going to write here? The value will be 1. Now, because the loop will run 3 times, this will continue. I guess everyone can understand this. Now what will happen? This value will be 2. This value will be 3. And this value will be 4. And then finally it's more like a linked list. If you have already done the linked list, you know that this log. And then what we have done, the fourth value will be assigned a null pointer. Remember what was the value of null pointer? Null pointer is -1. So what we can have here, we can have null pointer -1 over here. This is, you can say, initialization of binary tree creation time. We used to have this kind of thing. And if you see these values, null pointer is -1, free pointer is 0, and root pointer is also -1. So we can have here null pointer is -1, free pointer is 0, and the root pointer is also -1. These are the values that we have set up here. This is, you can call this whole part till here, that we can, okay, we can call this initialization of binary tree. Is it clear? So we now start, now the next code that we are going to write, how to insert values and set left and right pointer in binary tree. Remember, this is going to be a bit long, but hopefully this will explain you the whole code what we are going to do. Now the first thing we have said, do while free pointer is not equal to null pointer. If you look at the code, we have already have this. Free pointer is 0 and null pointer is -1. The condition is true that the loop will goes on. Console.writeLine, obviously this is asking an item console or any value that has to be asked. So what are we going to do? Let's suppose I want to enter the first value as f. The first value is f. Now what it's saying, if free pointer is not equal to null pointer, that is not equal to null pointer. So what is happening here? Free pointer is equal to new node pointer. Remember what was the value of free pointer? Free pointer is 0. So the new node pointer will also become 0 over here. Now we'll say free pointer is equal to B-tree free pointer dot left pointer. What this line is doing, very important line. This line actually moving the free list pointer, is indicating to the next pointer. Now it's saying B-tree free pointer dot left pointer. We can see here, what is the value of free pointer? 0. B-tree 0 dot left pointer is 1, and that new will move into the free pointer value over here. This value will become what? The 1. Is it clear? So we'll start. Okay. Now B-tree new node pointer dot data is equal to n item. New item हमने एक variable लिया हुआ है जिसके अंदर हम values enter करें, and that is f. So basically what's happened here? B-tree new node. What is new node? 0. 0 is over here. The data. This is the value. What the value will become? The value will become the f. The data will become the f. Right? So this is very simple. And then next line is saying what? B-tree new node dot. That's what we have done here. The value of null pointer will have been moved to the left and right pointer both. So what am I going to write here? I am going to write the left pointer will. Null pointer is -1. So this will also become -1, and the right pointer will also become -1. Is it clear? Now, if root pointer is equals to null pointer, then right now what the situation is, the first condition is the root pointer is equals to null pointer. You look at this. What is the root pointer here? Root pointer is -1 and null pointer is also equals to -1. So what we have done, the new node pointer is equals to root pointer. What's the new node? The new node pointer is 0. So the root pointer will become the 0. Right? Else this condition is not true. Else तो और कुछ नहीं होगा. The value will the loop will go up again. It will check whether the free pointer is not equal to null pointer. Obviously free pointer will go at the top. Yeah. Do while free pointer is not equal to null pointer. We can see here the free pointer is 1 and null pointer is -1. So it's not equal. It will again ask the process. Now what's happening? It's saying new to enter value. Let's suppose I have entered the value called C. Now remember, C is lesser than F. So it has to be gone on the left side. Remember this thing. This is very important, right? So how we are going to now set the tune here? That's what you're going to look at. Okay. Now again, if free pointer not equal to null pointer, right? Free pointer is equal to new node pointer. The value, so that we can insert the value. The free pointer value will be moved to the new pointer, so that we can enter the value. This value will become 1. New node pointer has become 1, and again the same operation when they say free pointer is equal to B-tree free pointer dot left pointer. So we will now the free pointer will point to the next free node. Okay, the next 3 data item that will be now. What is free pointer? 1. 1 ka left pointer is 2. So now the free pointer will point at 2. Is it clear? Okay. Now again, B-tree new node pointer dot data. As we know, new node is what right now? New node is 1. This is 1 data value is equal to new item. That the value will become what? The C. We will enter the value called the C over here. Okay, ji. We'll move forward. If root pointer equals to null pointer, right now the condition has changed now. Sorry. First thing. Now what we have done, again we have moved this null pointer to the new node pointer left and right pointer. So that means these two values will again become what? -1 and -1. Now the code will become, if root pointer is equal to null pointer, then no, else this node pointer is equal to else. Now this, because this condition is not true, it will obviously jump to num. Everyone knows about this. Root pointer is equal to this node pointer. What's the root pointer? The root pointer is 0. So this node pointer will also become what? The 0. Right? Do while this node pointer is not equal to null pointer. We know this node pointer is 0. Null pointer is -1. So nothing will happen. So just to save जस्ट टू रिमेंबर द नोड कि कौन सी नोड पे मुझे आगे करना है, मैंने यहाँ पे ये कोड लिखा है. This node pointer is equal to previous node pointer. This node pointer was already there. This node pointer was 0. So the previous node pointer will also become what? The 0. The previous node pointer will also become the 0. If b-tree dot data greater than an item, this node pointer is what? Right now, this node pointer is 0. 0 का डेटा है मेरे पास f और n आइटम क्या है मेरे पास c. Whether the f is greater than c? No, f is not greater than c. F is not greater than c. So then what will happen? Turn left is equal to false. If it is greater than, then turn left should be true. Turn left is equal to false, right? We write here turn left is equal to false. And then what we have done here, interestingly, we said b-tree this node pointer dot right pointer is equal to this node pointer. So we look at what is this node pointer? 0. 0 का right pointer क्या है? -1. And that -1 has been moved here. So that means this node pointer will be done -1. Why we have written these two lines? These two lines has been written to एंड लूप. ये जो डू वाइल वाला लूप है इसको एंड करने के लिए, टू एंड लूप, right? Now because what will happen now, because this pointer is now is -1, do while this node pointer is not equal to null pointer, लेकिन this node pointer भी -1 है और null pointer भी -1 है, that means the loop will be terminated. Now what we are saying, if turn left is equal to true, turn left is what? You look at here, turn left is false, turn left is false. So what will happen now? If turn left is equal to true, then b-tree previous node pointer new node pointer is equal to, is it false? So that means b new node pointer is equal to b-tree previous node pointer dot right pointer. Previous node के right pointer में new node pointer जाएगा. What is previous node? Look at here. Previous node is 0. 0 का right pointer में क्या चला जाएगा? New node pointer, that is 1. That is 1. Wait. If turn b-tree previous node pointer, okay, sorry, previous node. What is previous node? Previous node is 0. So f is basically, so it's going on the right, the value is here c. So this is how this code can be written, the whole code. Now if I will run this code, you will see the values automatically. Okay, enter value. First I have enter f, then I have enter c, d, e, and f. As I have traversed all this thing, it's pointing here. Now you will see what I have done. First I have print the right pointer and then I have print the left pointer. So you can see this thing here very clearly that okay. We start with this f के right pointer पे 4 है. What is right pointer is e, and then f के left pointer पे 1 है. ठीक है जी. So this is how these values will go on. This is what we call the binary tree code there. Okay, now we'll back to the presentation. Okay, I hope you have understand how to insert the values. Okay, deletion. Now we have inserted insertion. Now insertion has three types of options. Whenever we talk about deletion of a routine, it's a code that is written in Java. You can go through that. When we talk about deletion of a routine, a deletion code, deletion has three kind of cases that can be done. Now the first case is where the node that has to be deleted does not have any left or right node. The second case, will be where the node has a right node or a left node, and the third case will be where a primary node has both the nodes. So we need to deal it differently according to the requirement. Now look at here. This is one condition. This is if we will delete this node, we don't have to. We just simply delete that node and that's it. But what will happen if we have to delete this node, or we have to delete this node, this one, the top one, which is pointing? So for that, what we are going to do, we are going to delete this root node and we are going to connect this to it. And similarly, figure 3. So different type of deletions can be done over here. Now, just look at some pseudo past paper questions of this binary tree. The first question is says an order binary tree has 3 CSs here. They are like, this is past paper question, I think. Okay, create tree. A null pointer show that explain the meaning of the term null pointer. What is the meaning of the term null pointer? We have already discussed that null pointer meaning is what? A null pointer is a pointer which is which are not pointing to anything. Like -1 is -0 or -1 in programming language, 0 or anything that we can deny. Now you can see the following diagram shows an order binary after the following data have been added. We have Dublin, London, Berlin, Paris, Madrid, Copenhagen. Okay, now they are saying another data has been added and that data is Athens. What is the changes that can be done here? Athens. Now you look at it starts with here. Athens starts with A, so it is what? Lesser than A, right? You need to add a pointer value over here. Athens. Now A is also less than B, so it's going to be add to the right, to the left of the verb. Okay, because left pointer lesser, so it's going to point here on the left of the. Is it clear? The following diagram shows an array of records that store the tree. Okay, Ji. Now, how we are going to do this? First of all, tell me where the free pointer will lie. The free pointer will lie at, obviously, the free pointer will be pointing at 7. We have already seen in the code within the class that the free pointer is going to point at the number 7 because at the root pointer is 0. Now what will happen? When you enter Dublin, the root node is Dublin. Now look at the values over here. On the left of Dublin, what value will be there? After the D, it's going to be, so the left pointer will be what? Here you're going to write 2. Here you're going to write, you can see here. You can see here, Dublin is going to the Berlin is going to the left, while London is on the right. So you look at here, what is the value? On the left pointer, you will write 2. On the right pointer, you will write 1. Is it clear? Similarly, when we move forward, now we look at the next thing, London. London is only pointing to Paris. And where it is? On the right side of this. So London is pointing to Paris. That means where you are going to write the value will be what? The 3. Similarly, you are going to fill this thing, a very easy question of 5 marks. Just need a basic understanding of this thing and you will be able to catch up this. Give an appropriate numerical value to represent the null pointer for this design. What you value will think you will have for the null pointer? Is it going to be 0 or is it going to be -1? This is going to be -1. Why this will be -1? Because it is basically we started the array element with 0. So if you write, if you have 0, so -1 will be the logical value because we started the array element with 1. With the 0. They have given a program is to be implement the variable procedure to be used listed below. You can see data structures, node, left pointer, right pointer, almost the 3 things जो हमने किए हैं. Right pointer data, they have given this create tree, add to tree, find insertion point. These are the procedure. Obviously, they have written this thing in the procedure form. Complete the pseudo code to create an empty tree. जी भाई क्या लिखेंगे यहाँ पे? We are going to write declare data string. It's up to what kind of data. If it is string, we're going to get string, and then the left pointer and the right pointer, and then declare tree 09 as declare tree 09 as node. Declare free pointer, declare root pointer. That's what we have done. Now this is the code that we have done this. Declare index integer, then you're going to declare have the null pointer over here, the free list pointer, the loop that will done, and then you're going to write the same line that we have run binary tree dot left binary tree dot index dot left pointer is equal to index plus 1, and then the last line will be this. It's again a easy question, very easy question of the 7 marks that can be easily obtained from here. If free pointer is equal to null pointer, then obviously no space left. Else, that we are going to do, free pointer will be new node pointer. Adjusting free pointer, we have already understand how we're going to adjust the free pointer. Free pointer will be what? The whatever the value array name will be there. I guess we have that free. Yeah, free list pointer. We can adjust this thing. It's a very simple code. I will show you the answer marking scheme of this. So you will see this, how these codes are going to work out. Again, complete the recursion process के साथ भी लिखना होगा. We can have this kind of answers also. I will show this answers. Again, a question is coming. Create tree, add left, red, green. The following diagram current state the binary tree. Now we have to basically add these values. Attach right black comma 2. Basically, you need to write the values. Similarly, you can see what it say here. रेड से 1 पे गया है ब्लू एंड 2 पे आ गया है green. This is what line. Now what is saying? Attach right black comma 2. So we'll see this. This is again a tree-like structure that can be done here with this. I will show you the MS down here. Create tree, add Dodi, add Ferrari, add Ali, and then you need to basically tell what's the root pointer, the left pointer, see the canary. These are the same questions that can be done easily. A programmer needs to write an outputting item in ascending order. Basically, you need to write the traversing tree here. Just need to show you. Yes, that's what we have seen here. Like you can have either -1. That's what the question that we see the MS of this thing. So it's basically showing you that like the Dublin, London, the Dublin 2 is will go to the Berlin. Point 2, the value there, and then 1 London. This is what we've discussed. You can see the MS of these things. Again, type node, left pointer integer, right pointer integer, data string. Declare array of the node. That's what we have already discussed. Declare root pointer is equals to -1, free pointer is 0, index +1, index dot right pointer -1, or leave left pointer -1. We have set up this thing there. That's it. What their answers will be if direction. If pointer is not equal to null, then traverse tree dot pointer to left pointer, output tree pointer. Obviously, if not null है, तो direction के साथ हम काम करते चलें. These are the code there, which can be done. I will forward these worksheets to Sir Zafar. So that's it from my side. Look at this. This is also part of question here. You can see the red is pointing it to the blue, the values, the 6 and 7. Similarly, whatever the values are there, pointer you need to write the values, and then the question will be written like this. So it automatically be coming here. The values you just have to point to the left and right pointer, and the values will become. This is how it's going to work out there. This is the code to find a leaf. You can easily see that it's written in BB that if binary dot current node not equal to -1, not equal to -1, that means it's pointing on something. Then find leaf binary tree dot current dot left pointer. Similarly, this is basically pointing on something. We have already seen this that uh, 2D is pointing to the band, and then the value that is shorter are going on the left side, that is or they on the right hand side. That is happening here also. This is the way we're going to write the left and right pointer. over here. Lodi, Ferrari, procedure, traversary, value, traversing if road or left one not equal to run, then not equal to 0. 0 here. Right now they have taken the the null pointer as 0. It depends. If you can have also have the minus one depending on the condition. This is the already procedure given traversary. It's going to be called again and again itself. So Zafar, that's it from my side. अगर आपको कुछ और ऐड करना है तो kindly ऐड कर दें.
Thank you very much, sir. I think it was good enough, and nothing can go better than this in this short time. I just want to, sir, be with me. I want to talk about something else, and then we will wind up the show together.
Yes, sir.
I wanted to talk regarding current situation in Pakistan and in our city, especially. Due to this corona, many of the people are needing us. We as Pakistani are the best nation in the world, being one of the most philanthropic nations in the world. Everyone is admitting it. I have researched it today, even over BBC Travel. I was looking into a report, and that said that according to a report by Stanford Social Innovation Review, Pakistan contributes more than 1% of its GDP to charity, placing it among far wealthier countries like United Kingdom, 1.3%, and Canada 1.2%, and around twice what India gives relative to GDP. And a nationwide study found that 98% of Pakistanis give to charity or volunteer their time, a figure that far exceeds the number of people who are legally obligated to offer Islamic charity, even zakat. Pakistanis, I am sure that Pakistanis are bonding together to assist the less fortunate. When 2005 earthquake happened, I studied in a report, I saw a report from the BBC reporter that Pakistanis are the nation, Pakistan is a nation where less fortunate gives charity to even less fortunate to them. So everyone who has less money, so this is a wonderful thing. I know that Pakistanis are bonding together to assist the less fortunate in a unique and inspiring ways. Especially many are offering zakat, the traditional Muslim charity, for daily wages earners who have no paid leaves, health insurance, or financial safety nets like us. I am fortunate, whatever happened, but it is in control. We are at home, but things are in control. We are fortunate that we are being paid, we are having leaves and everything. But please do think about those who are actually, they cannot afford to have daily food. 25% of Pakistanis cannot afford to eat 2 times a day. As the COVID-19 situation prevails, it forces people to stay home. People are dying. Back 2 months back, whenever I talk to anyone about this COVID and coronavirus, and they said that, have you seen anyone in your relatives, your friends, in your neighborhood who is dying? It is not true and all. Now I can say that many of the people in my friends, in my known relatives, their friends, they are dying. They are on ventilators. It doesn't give you time to think and all. So it is always a good idea to be at home, be safe, and do as much as you can for others. Let them pray for you. Let them pray for this situation to go as soon as possible. As the COVID-19 situation prevails, it forces people to stay home. And we should know that many daily wage earners here, from street food vendors to shoe shiners, cobblers, now haven't earned a rupee in weeks and they are going all hungry. How can we sleep? How can we stockpile our pantries when there is someone sleeping in our neighborhood hungry? Their children are hungry. To find them out. It is not necessary that you should be giving charity a lot. It might be less, it might be more. It's as per yourself. A rupee can bring a bigger difference. So do not doubt people. Give them charity. If it is not the financial aid that you can provide, do it with your contacts, do it with your relations, do it by your hand, go on foot and help them. Keep yourself safe, healthy, and please take care of all the precautions that you have to in order to keep your family safe. So this was my message today, and let's see
Yes,
if there are any questions.
yes, sir. Just
So you
want to
want to
add
say
one.
something, sir?
Yes, sir. Just want to add one thing. They try to tell people, convince them that the pandemic is reality. It's in Hadith. It's there. It's a reality. It's not a hoax. It's a reality. We are seeing it now. Actually, it's happening. Please tell them, like if they are going out, take proper safety measures that are there. Wear gloves, mask, use sanitizer, wash your hand. Whatever you do, I know it's not difficult to stay home for that long. We are not prisoners like this. But if you are going out, please take all the precautions. Tell others it's a reality. Don't look at the
Yeah.
rumors, please.
Even making people realize that it's not a hoax, it's a reality, is a charity. It's
Seriously, seriously.
something which you should do. You should realize yourself and you make others realize. You never know if someone carries this virus, that virus might not have affected them, but they may affect many people.
Many do.
We have children around, we have elders around. We are fortunate to have good health, but no one know that
But
what could happen if we are not secure and we do not take these precautions. Anyways, sir, there are no questions,
okay, sir.
so let's call this live feed off.
Okay, sir.
Thank you very much, everyone.
Thank you, sir.
Take care. Take
Thank
all
you, sir.
precautions, sir.
Okay.
You want to say something,